Large amounts of online reviews are available on the internet. According to the investigation of Bright Local, nearly 90% of consumers trust online reviews as much as personal recommendations. Online opinions are truly goldmine of information for business. Given a data with 12,000 reviews, how can we excavate useful information from them to know the sentiments of consumers in specific products to facilitate the decision-making process? Our goal is to build a model that can identify meaningful words from reviews to predict the customer's sentiments about a specific product so that it can suggest data-driven marketing strategies to our client. We have three steps to achieve our goal. The first is data understanding and preparation. The second is feature construction and selection. The third is model selection and evaluation based on the selected metrics. The dataset we have the 6,000 camera reviews, but there are only 487 relevant to the Fuji camera, which is our analytical focus. Even among these reviews, there are 90% yes label reviews and only 10% no label reviews. We have a very imbalanced dataset truly. We generated word cloud based on the frequency of words that appears in reviews. As we can see, for the Fuji yes camera review, people generally talk about digital quality, battery, card, and so on. Let's look at Fuji no word cloud. We can see Fuji words has appeared more as compared to reviews under the yes label, suggesting people use brand name to write the complaint, which can highly impact this brand. Before performing advanced analysis, we do some pre-processing of our data. This includes removing punctuations, unwanted characters, stop words, and the most infrequent words. Finally, we successfully reduced the number of features to about 3,800. Next step is feature engineering. We created a bag of words features vectors from reviews. While different approaches for parameterization of text are available, we choose to implement TF-IDF, which emphasizes rarely used terms on the reviews. Since the number of features was much more than the number of reviews, we feel that our model would overfit if we used all these features. Thus, we decided to reduce the dimension of features and transform the data representation into a shorter and a more predicted one. In our project, we choose to implement chi-square, which is a feature selection technique. The third step is model selection and evaluation. Given that our data's output is binary, we choose three types of model: support vector machines, random forest, and logistic regression. They all have their pros and cons, especially for SVM. Since it's black box interpretation, we only use it as contrast. The metrics we used is F-beta and accuracy. We used cross-validation to split the data into A folders for training and testing purposes. This slide depicts steps within the cross-validation loop. Based on our experiments, the score of F2 and accuracy are on the table. Apparently, random forest has better performance than the logistic regression. In the ROC curve comparison, we can also see random forest has better performance than the logistic regression. Result: important feature words were identified by using random forest model to predict the negative sentiments. Words like poor, terrible, returns depicts a lot about the unsatisfied customers. Based on this result, we can make few recommendations. First, customers have complaints about the picture quality of this camera, so Fuji should look into this specific issue and rectify the problem. Second, customers are unsatisfied by Fuji's service, and to maintain the customs report, Fuji should build custom relation method. That's all. Thank you.